Welcome to Learning with UNP. In this session of Python for data science, we are going to understand about list that includes introduction to lists, indexing in lists, and finally understanding the characteristics of list. Let's begin with understanding about list. A list is a versatile and commonly used data structure in Python that allows you to store an ordered collection of items which can be of different types. Lists are mutable, meaning you can change their content without changing their identity. They are similar to arrays in other programming languages but are more flexible in terms of the types of data they can contain. Lists can contain elements of all data types. Lists are defined using square brackets and elements are separated by commas. Each element or value that is inside a list is called an item. Now let's understand how to create a list. Creating a list in Python is easy and straightforward. You simply enclose the elements in square bracket separated by commas. Here is the syntax of it. My list equal to element 1, element 2, element 3. This line creates a list in Python named mylist that contains 3 elements. Each element is separated by a comma and the entire list is enclosed in square brackets. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist means create a list named mylist. Step 2. Add elements to the list separated by commas means add items to mylist separating each one with a comma. This example demonstrates how to create a list in Python. We create a list called mylist that contains the numbers 1, 2, 3 and 4. Then we use the print function to display the contents of the list. Let's execute and check. Here is the output. Now let's understand about the data types that a list will deal with. Python list can contain elements of different data types altogether. This means a single list can include integers, strings, floats, and even other lists. This example illustrates the versatility of Python list. The list named mylist contains a variety of data types within it. There's an integer 1, a string hello, a floating point 3.14, and another list inside it which contains 246 elements and a boolean value true. The print statement is used to print the output. Let's execute and check. As discussed, here is the output. Now let's check how to determine the length of a list. The length of a list can be determined using len function, that is length function. This function returns the number of elements present in the list. The syntax to do this is mentioned here. This line calculates the length of the list mylist and stores it in the variable called length. This means it counts the number of elements contained within mylist and assigns that count to the variable length. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist means create a list named mylist. Step 2. Use the length function to determine the length of mylist means find out how many elements are there in mylist using length function. Step 3. Assign the length to a variable length means store this count in a variable called length. This example shows how to count the number of items in a list. First, we create a list called mylist, which contains various types of data such as number, string, float, a list itself, and a boolean value. Then we use the length function to count how many items are there in mylist. This count is stored in a variable called length. Then we print the output using the print statement. Let's execute this and check. As discussed, it gave the count of items in the list. Now let's look at indexing in Python. Indexing in Python allows you to access individual elements in a list. It can be done in two ways: positive indexing, negative indexing. Positive indexing involves accessing elements from the beginning using zero-based indices, whereas negative indexing involves accessing elements from the end using negative indices. Here is the syntax to do so. These lines of code demonstrate how to access elements from a list in Python using both positive and negative indexing. That is, depending on whether we are counting from the beginning or the end. For positive indexing, you specify the index of the element you want to retrieve, counting from the beginning of the list. For negative indexing, you specify the index counting from the end of the list. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mylist, means create a list named mylist. Step 2. Use a positive index to access an element from the beginning of the list, means use a positive index to specify the position of an element you want to access starting from the beginning of the list. Step 3. Use a negative index to access an element from the end of the list, means use a negative index to specify the position of an element you want to access counting from the end of the list. Step 4. Assign the accessed elements to respective variables, means assign the elements that were accessed to their respective variables. This example demonstrates how to retrieve elements from a list using both positive and negative indexing. In this example, we create a list called mylist containing various data types. By using positive indexing, we access the element at index 1, which is hello. Positive indexing counts from the beginning of the list, so the second element is retrieved. Additionally, we use negative indexing to access the element at index -1, which represents the last element of the list. Since negative indexing counts from the end, -1 corresponds to the last element, which in this case is true. After accessing the elements using both positive and negative indexing, we print the output using print statements. Let's execute this and check. As discussed, the element at index 1 is hello and the element at index -1 is true. Finally, let's look at the characteristics of list. First comes ordered. Lists are ordered collection, which means that the items have a defined order that will not change unless explicitly modified. This order allows you to access or retrieve the elements based on their position in the list. This example demonstrates the concept of ordered collections in Python list. In this example, a list called mylist is created with 5 integer elements 1, 2, 3, 4 and 5. These elements are separated by commas and are enclosed in square brackets. When the print of mylist is executed, the contents of mylist are displayed. Let's execute this and check. As discussed, it displayed the contents of mylist. Second comes mutable. Lists are mutable, meaning you can change or modify their content without changing their identity. This flexibility allows you to add, remove, or modify elements after the list has been created. This example demonstrates the mutability of list in Python. We start with a list named mylist containing integers from 1 to 5. Printing this list reveals its original contents. Then we modify the first element of mylist by replacing the value at index 0 with 10. This demonstrates the mutable nature of list in Python, as we can change elements after the list is created. Upon printing mylist again, we observe the updated list with the first element changed to 10. Let's execute and check. As discussed, the original list contained the original elements. After changing, the first element has been changed to 10. Third comes duplicate. List can contain duplicate elements. This means that you can have multiple occurrences of the same value within a list. This example highlights the capability of Python list to include duplicate elements. In this example, the list mylist is initialized with integers including the duplicates such as 2 and 3. Printing mylist displays all elements in the same order they were inserted. Let's execute and check. As discussed, they are printed in the same order that they have been inserted. An important point to be noted here is, even though there are duplicate elements in the list, each element maintains its own identity within the list, regardless of whether it appears multiple times. This property enables list to represent collections of data where repetition is mandatory. This is all about today's lecture. See you in the next lecture. Thank you.